Hi. So welcome to the York University Astronomy and Astrophysics radio podcast. This is written and presented by the students, faculty, alumni, and friends of York University. You can find us now wherever podcasts are distributed, so we do have it on quite a number of different platforms. I will be one of your hosts this evening. My name is Mary Helen Armour. I am faculty here at York University, and I'm joined by Paul Mackin, who is a student at York in the astronomy program. We are broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday night at 9 p.m. local Toronto time. Or if you work in UTC, as many astronomers will, this would be Tuesday morning. Currently, it's 1 a.m. Universal time for Eastern Daylight or for daylight time. And we are on YouTube at York University in concert with the online public viewing program run by the Observatory team, who have a great series of images tonight. Unfortunately, the weather isn't so great for live observing, but they have some wonderful images to show. Okay. To navigate to the live show or find out more, you can check out our website. It's at www.yorku.ca/science/observatory. You can also just search for the Allan I. Carswell Observatory, York University, and this will come up as well. Okay. And you can then follow the links to the online public viewing. And there is currently a live chat on YouTube that runs simultaneously, where a bunch of our students who support this program can answer any questions you have. If you have any questions or comments on any of our past shows, or if you have any suggestions for future topics, you can please email us at observe@yorku.ca. And you can also connect with the York Observatory on Instagram with the handle @YorkU Observatory. Or they also have a Facebook page at the Allan I. Carswell Observatories. Okay. Any programs that the observatory runs are all free, but the observatory does appreciate any donations people are willing to make to allow us to sort of expand and improve our programs. Okay. Again, we will be monitoring the chat room for questions and to post any content that we need. Currently, the weather is quite cool here in Toronto. We're down near the freezing, and it is unfortunately quite cloudy. So the images they will be presenting on the online public viewing ones are sort of images from other viewing sessions. So if we're looking at tonight's show, then my fellow presenter is Paul Mackin. And tonight, given that we had a recent lunar eclipse, and there is actually an upcoming, at least partial solar eclipse on sort of around March 29th that will hit the eastern coast of North America, we're kind of looking a little bit at sort of the moon and some lunar exploration and some of sort of the early rocket missions that have happened. So welcome, Paul, who's here to join us this evening. I hope you are, haven't heard from you yet. I hope you're online, okay?
Oh, I'm fine. Thank you. Yeah, great to be here. And it's unfortunately it is we had sort of a nice break in the weather, and then it's now it's gotten nasty again, and it looks like it will be for a few more days. I suppose that keeps me in at night, which is probably a good thing, given that the end of term is coming as well. So, and I've got a lot of assignments due, but it's great to be here.
Yeah, March is generally not a great observing month because it does tend to be quite cloudy. And it doesn't even have to be snowing or raining or whatever nasty form of precipitation we're getting. It's just there's enough cloud and enough haze and stuff that unfortunately March can be a bit of a rough month for observing, but hopefully next week they'll get some better weather to get some lovely images. So we usually start these things out as always with a little bit of history and talking about the moon. With the invention of the camera in the 1800s, people began taking pictures of everything, of course. So on March 24th, 1840, this is when they actually took the first picture of the moon. So what you're getting, unfortunately, we're not likely to see much of the moon tonight because we're moving towards the new, which is why we can get a partial eclipse of the sun. And of course, a little while ago, we had sort of a lunar eclipse. I'm sure the observatory staff has some lovely images of that. I know I saw quite a few that were taken by various contributors. So that was really kind of fascinating because in some ways that's a bit, astronomy is a fascinating topic. And every time we get these technological advances, we learn new things. So 1840, we could actually take a picture of the moon, and this led to sort of a whole different kind of observing where we started to take images of things rather than just sort of looking at them through a telescope and trying to sketch them out. So the development of the camera was the first one. And technology since then, I think, has really improved things. Um, Technology, when you talk about the moon, of course, that took us to lunar exploration. It's a bit of a hot topic right now because, of course, NASA is trying to get to the point with new rocket to development to actually get people back to the moon. Many people sort of listening to this broadcast may not have been alive when the first moon shots happened. Um, and the earliest rocketry goes back into sort of late 1950s or to 1960s. In 1961, on March 24th, they actually had the first Mercury Redstone was launched. It was an unmanned launch. It was actually one of the last uncrewed launches because after this, they got into putting up astronauts into space. Okay? So I'll turn it over to Paul to talk about sort of one of the next sort of big launches from this sort of week in science that relates to the moon then.
Yeah, so on March 24th, 1965, so I guess that's 50 years ago. No, 50, yeah, 50,
60.
50, 60 years ago. That's right. 60 years ago. I would have been 5 years old. The Ranger 9 mission successfully impacted on the moon, transmitting high resolution images all the way down. Now, this is kind of a milestone mission. It's quite a fascinating story, actually. You might think, crashed on the moon and this is a good thing? That's what it was designed to do. Between 1961 and 1965, NASA and the JPL launched a series of impactor missions to the moon. They were designed to crash. And given the technology of the day, and we're trying to do something, I mean, think about it. 6 years, 7 years earlier, the US had never launched a rocket successfully into orbit or even suborbital. So they were given the technology they were trying to do something they'd never done before. And when they got to the Ranger series of missions, they launched 9 of them, and the success rate of these missions was incredibly poor. But they had to develop, systems to navigate to the moon. You're on Earth, you're launching a rocket, okay, you know how to launch a rocket, you've been doing that for a few years. Then you have to move the rocket fast enough to get out of Earth's orbit and on the way to the moon, but you don't really know how to get to the moon. You've never been there before. So you've got to figure out, and that's actually kind of a complicated thing because what you have to do is you have to aim for the place where the moon will be in a couple of days when the spacecraft gets there. It's sort of like Wayne Gretzky saying, I'm not trying to shoot the puck, at someone. I'm trying to shoot the puck where someone will be so they can get a goal. And so you're aiming for where the moon's going to be. They have to figure that out. You have to figure, and then once it's going, you maybe have to adjust the course a little bit. And how do you do that? And that means you have to communicate with the spacecraft. And so there's a lot of things that you really have to develop. And then you've got to actually get the images. You're coming into the moon, you're going faster and faster because gravity, it's pulling you in faster and faster, and there's no air up there to slow you down. You're going in faster, faster, faster. And at the same time, with 1960s technology, you're taking a picture and sending it back to Earth, and then taking another picture and sending it back to Earth. And eventually you're going to run out of time because bang, you crash into the moon and you make a crater. So, they had a lot of technology problems they had to solve. So there were 9 missions in all, but only 3 were successful. Rangers 1 and 2 failed on launch. They never got off the ground. 3, 4, and 5 missed the moon. They just they didn't aim it right. 6 successfully impacted, but its cameras failed. So again, we've worked out all those bugs, and now we've got Ranger 7, 8, and 9. And they were able to capture images and transmit them back to Earth before creating new impact craters on the lunar regolith. Looking back on it, given the technology of the day, it's amazing they were able to do any of these missions successfully. The Rangers were part of a 3-pronged unmanned mission approach, which was designed to further the stated US goal of landing someone on the moon before the end of the 1960s. So Rangers came first, get to the moon. Then we had the lunar reconnaissance orbiters or the lunar orbiters. Their job was to fly around the moon and take a whole bunch of pictures looking for possible landing sites. And then finally, there was the Surveyor program, which was designed to land on the moon and understand how to land and also understand the characteristics of the lunar regolith of the soil because they didn't know. They didn't know if it was gonna, if you were like landing on quicksand and the spacecraft would sink. They thought it would be okay, but you have to test these things. So this was all part of an ongoing mission and to get people on the moon. And the very last of these Ranger spacecraft launched 60 years ago today.
And it's quite fascinating when you look at sort of the space travel. And we look back at the 60s and you think, oh my God, they only sent back 10 images. But if you think about the comparative technology at the time, it was an amazing accomplishment. And although a bunch of the Rangers failed, let's be honest, we're still having failures today, 60 years later. I mean, we saw in sort of recent months how 2 of the SpaceX, you know, they've been launching a fair bit. 2 of the SpaceX still, did not successfully launch. And you had the Blue Ghost that recently landed on the lunar surface that also had problems and didn't really land all that successfully. So, like what's happening with the Rangers, it's still going on today. Space travel is a very, very difficult kind of proposition, even to something as close as the moon. The fact that they actually managed to get a bunch of Apollo astronauts there and back with no fatalities, if you think about it in terms of the technology and some of the challenges they faced, it was pretty amazing at the time. Um,
Oh yeah, what they pulled off was incredible. And I've actually gone back and looked at the Ranger images, and you're right, they've only got, a dozen maybe from each spacecraft, maybe a couple more than that. But they're exciting to look at because you can see the moon from a distance and it's getting closer and closer and closer. And then suddenly you've got that last image and it's a half frame. But because the spacecraft, failed, crashed before it could transmit the thing back. And but this is actually a tried and tested strategy. You basically expect to fail and you use your failures to teach you what to do right next time so it hopefully gets better, and the strategy has worked.
oh yeah, and it's overall the space program has probably had, especially in recent year, more successes than failures, but failures are part of the process. So looking at bits of other history on sort of this day or this week in science, if we talk about moons, obviously planets beyond Earth also have moons. And in 1655, this is when Christian Huygens actually first discovered Titan. And Titan is one of those fascinating moons in our solar system because it is sort of the only moon in our solar system that we know of that has a thick atmosphere. It's quite an interesting object. But this was, first discovered in 1655. Huygens was, a fairly active astronomer at the time. Like most astronomers, he would have built his own telescopes, ground his own lenses, that kind of thing. And he was the first to discover Titan, yet another moon in our solar system. And this was sort of very typical of the time where there were a lot of these discoveries going on, Galileo in the early 1600s, but again, this is all technology related. Suddenly you had telescopes, and from sort of Galileo first using a telescope, he didn't discover or invent the telescope, but he was the first one to turn it on the sky. And then you have sort of more and more astronomers building bigger and better telescopes. So it's that technology and that testing again. And it led to whole suites of discoveries. Obviously, the moons of Jupiter were some of the first, and then you have the moon of Titan, and you sort of just keep making more and more discoveries as the telescope sort of expanded our understanding of sort of what was in the solar system. And I think Paul, you had some stuff too you were looking at on Mars and some of the early discoveries.
Yeah, so if we go back to the late 1890s and and early in the 20th century, there were incredibly detailed maps of Mars were made. This was visual observing through a telescope. Percival Lowell was one of we've talked about him in other podcasts, but he was one of the main people doing this. And in telescopes, it was very clear that Mars had an atmosphere and it had polar ice caps, which uh, grew and shrank in what appeared to be seasonal behavior. Um, and but these maps showed an incredibly detailed set of canals interconnecting various points on the surface. And it was, I mean, they kind of put all the pieces together. They said, well, there's polar caps, which probably means there's water. And there seemed to have a distribution network for this water. So maybe this is purposeful. Maybe this is, intelligent life. And these points where the canals all meet, maybe those are cities. And they built up this view of Mars that was populated. They didn't know what the people there were like, and it had water and it was habitable. And it seemed that they were, going to have a populated planet. So, as part of that, there were a series of Mariner missions in the 1960s to explore, is Mars habitable? What's it really like? So we start off with in 1965 with the Mariner 4 spacecraft to fly by Mars, and that was its mission. It was going to fly by Mars and send back imagery. When the first pictures arrived, and they only got a few shots, I mean, they didn't really, think getting to the moon was hard. Getting to Mars was a lot harder, much further away. You've got much more complicated communications, networks to deal with. You are going to fly by, so you're not crashing. So you can hopefully store some images and send them after the flyby. But they've got the spacecraft, it's on its way to Mars. And when the first pictures arrived, lo and behold, Mars looked a lot more like the moon than Earth. It was heavily cratered. The atmosphere was much thinner than expected. The temperature was very, very cold. The atmosphere was like a thousandth that of Earth, and the temperatures were like 100 below 0 Celsius. And suddenly, it didn't look so hospitable for the Mars life enthusiasts, right? So as a follow-up, Mariner 6 and 7 were designed to fly by Mars, and Mariner 7 was launched on March 27th, 1969, which is 56 years ago this week. Between Mariner 6 and Mariner 7, it's the spacecraft that was launched now, they returned photographs of approximately 20% of the surface. Now, again, they were just flying by, but they were timed to cover a fair bit of the surface. And again, they showed heavily cratered regions of the planet. And because of the instrumentation they carried, including an infrared spectrometer, the volume of Mars science increased massively, which included a detailed breakdown of the planet's atmosphere, and it was found to be mostly carbon dioxide. They got further they got further information on the temperature, and it was very cold. So suddenly the idea of life on Mars, instead of being a real thing, got relegated to songs by David Bowie and not much else. But following this mission, Mariners 8 and 9 were the first probes to go into orbit around Mars, although I think Mariner 9 failed. And then after that, they had Viking 1 and 2, which were two lander orbiter missions. And then now we've got a modern fleet. After Viking 2, there were no missions, I think, from 76 until 1990, 1997, with the Pathfinder mission, and Sojourner. And then now we've got a whole bunch of landers and orbiters. We've got multiple orbiters from many different countries in orbit around Mars. And I'm sure that we've talked about them here on this podcast as well. So a lot of our listeners are probably very familiar with them.
Yeah, I mean, the whole Mars exploration was kind of fascinating because some of that early work by Percival Lowell and others is you can still see it in the science fiction that we write about Mars. And particularly in that era, Edgar Rice Burroughs, if you've ever read any of his Barsoom novels, and this led to that movie John Carter of Mars, if you look at that picture of Mars, it's really what Percival Lowell first imagined looking through his telescope. That whole sort of picture that he had of Mars very much influenced what Edgar Rice Burroughs and some other science fiction writers sort of wrote about Mars over the next few decades. I mean, H.G. Wells' very famous War of the Worlds that sent New York City into a panic really drew on that sort of picture of Mars as this sort of, habitable planet. So those early Mariner missions that brought back real images, I think, were a real disappointment to a lot of people and sort of, changed really, I think, a lot of how we viewed Mars, but this sort of earlier science fiction still kind of tags along with us when we talk about, the possibility of Mars being habitable. Uh, and so again, it's just fascinating when you look at the history of how we changed so much from what we saw on Mars, through the first telescope observations. I mean, even people like Marconi in the 1920s was telling people to tune their radios to listen for Martians when Mars was at a close approach to Earth. So we really did believe in Mars as an inhabited planet, and that's so changed with, the Mariner missions in the 1960s. Our whole sort of understanding of Mars um, was like. Um, so it's like that technology that shifted so much of what we thought about Mars was kind of a fascinating thing that was going on in that time period, I think.
Yeah,
Another
yeah,
sort of
it's incredible because I remember I was probably 12 years old reading a book by Robert Heinlein called Podkayne of Mars. And it was written just before the space race got going. And the view, he was considered a science fiction writer. And the view he had was that, Mars was kind of basically habitable, but very cold at night. And um, Venus was kind of swampy and hot, but you could very easily have human civilizations. And maybe they were both habitable with their own native life forms. And, not that many years later, that's out the window because science changes. One of the things about science, it's dynamic. You're always up getting a new information which updates your worldview. And modern writers, now talk about colonizing Mars. And, there's a very good series by Kim Stanley Robinson called Red Mars, Green Mars, and Blue Mars and Green Mars, which is about humans building a civilization on Mars as well. So,
Yeah.
and that's considered much more scientifically modern and accurate.
Yeah. And you can sort of see the shift in the science, also in the science fiction. Because it's like I said, I also read Heinlein when I was younger. But now you have more recent authors like Ben Bova, who talks about sort of some of the first human landings potentially on Mars that follows the science much more closely to what we know today. Another interesting sort of one in history in the last much sort of closer recent times, of course, in 1997, and I still remember this quite clearly. The Hale-Bopp made its closest approach to Earth on March 22nd of 1997. So about this time of year in 1997, Hale-Bopp was really visible in the night sky. I think it was the last comet that I remember being quite so clear and quite spectacular. Of course, there were some strange things that happened around a number of cult groups, but this was sort of, I guess, one of the more spectacular comets to have visited the inner solar system in um, recent years. So that was sort of another thing that went on in sort of this week in sort of astronomical history. Another sort of one coming up, sort of reminders. Later this week, March 29th, if I'm reading all my news right, you'll have the first solar eclipse of the year. It will only be a partial eclipse. It will only sort of graze the sun, but it should be visible from eastern North America. I don't know how much of it we'll be able to see here in Toronto. But again, remember, never look at the sun directly when you're having during any kind of eclipse because you can, damage your eyes doing that kind of thing. But March 29th, you may notice during the day, because it's a partial eclipse, it won't get fully dark. You may get some darkening of the sky, though.
Yeah,
Um,
this with this eclipse, it's interesting. It's actually quite a bit of coverage. It's 90%, 90 plus percent, but that's over the northeastern Arctic Ocean, north of Iceland. And when you get to Canada, you get a bit at you'll get some coverage at sunrise in eastern Canada, even a little bit of coverage in eastern Ontario. But once you get to the GTA, I think you can expect up towards Barrie, Ontario, a 0.2% coverage at sunrise. And then when you go any further south, nothing.
Nothing.
So where I live in Newmarket, Toronto, none of that. You're going to get no coverage. But for the eastern part of the province, at sunrise, there will be a little bit of it. And then as you go further east, it gets better and better. I've got friends in Newfoundland, and assuming they're clear, they get clear, they've got clear skies that morning. They're going to try and send me some pictures.
So, yeah, it's like I said, and eclipse chasing is something some people spend a lot of time doing, like knowing when the next one is coming and where they have to go, because it's like I said, it varies quite a bit on the globe as to where it is visible. This time, we're not really getting much of it in this area, only a tiny bit will be visible. But, if you happen to be in Newfoundland, you might get much more of a show this time around. Since we're about halfway through, just a reminder, you are listening to the York Universe broadcast. We are broadcasting live from the Allan I. Carswell Observatory, located at York University in Toronto, Ontario, Canada. Again, we have our webpage at www.yorku.ca/science/observatory, where they have a chat going. There are questions. There's content there. Of course, this is live on YouTube. But we do also have sort of students answering questions that people might have. So tonight you're listening to myself, Mary Helen Armour, and also Paul Mackin. And we're discussing sort of a variety of topics around the moon and around some space exploration. Um, But if you're also sort of interested in the online public viewing, again, at the observatory, if you click on the OPV, the online public viewing, unfortunately tonight, the weather conditions are not that great, but we have a great bunch of students who are bringing you some other really great observe images on this web page. Um, so in the second half, we're kind of looking at sort of things in the news. The first half, we do a little more history. The second half, we do a little bit more sort of in the news. And, like there's always some interesting things going on in astronomy. And I think, Paul, you were looking into ESA's Euclid Observatory and some of the data they released. I know a couple of the students had some great images before we started this show coming out of the Euclid data.
Yeah, so this sort of lines up in a way with a story we've been talking about over the past couple of months about the Vera Rubin Observatory that's coming online. One of the things that happens with sort of these big observatories now is they collect data, and then after some processing, and there may be other drivers than just, you know, crunching the data a bit. It's generally released to the public. Some examples of that. Well, Vera Rubin is going to release a data set every year, and it's a lot of data. I think the web, they have a program to release data on a regular basis. One of my favorite is the Juno mission at Jupiter, which wasn't even going to have a camera when it was launched, but part of public outreach, NASA decided to put a camera on there, and it's been this incredibly successful uh, tool for getting great images of data, which are entirely processed by the public. NASA isn't really doing much with those images. The images are made available, and a lot of citizen scientists, as people fashion themselves with complete justification, process these images. And if you go online and you look up, Jupiter images from Juno, you'll see some amazing pictures, all done by members of the public and not really so directly by scientists working on the Jupiter data. But one of the observatories is the European Space Agency's Euclid Observatory. It's going to release its first data, or it has released just last week, I think on the 19th, its first data set to the broader public and scientific community. And this is a big deal. Euclid was launched on July 1st, 2023, and it has a 600 megapixel camera. That's a really big camera. I think if you've got a top line, SLR or a mirrorless camera, that's maybe got a 40 megapixel camera, or your iPhone, if you've got or your whatever your phone is, if you've got a latest generation phone, this is 15 times bigger than the best phone you're going to get for home use type thing. So it's a big camera. It records images, but more importantly, it's also got a spectrometer, and it's recording redshift. So let's talk about that, because it sort of ties into the mission. Redshifts are the the amount that light is shifted towards the red end of the spectrum because something's moving away from you. So it gives you an idea not just of what it looks like, but the velocities relative to Earth of all of these objects. Now, this is key, because what you can do with that is you can start to build up a 3D image, which is why Euclid was famous for building 3D images, the techniques to develop 3D images. And Euclid is doing exactly that. It is trying to build a 3D image of the universe, going back to up to 10 billion, going out to up to 10 billion light years, which means we'd be looking, building a map of a 3D map of the universe, going back to when the universe was less than 2/3 of its current age, about 3 billion years. It's also investigating how dark energy is contributing to the evolution of the structure of the universe. Now, this is, quite an important topic. We don't really quite understand yet why the universe is behaving the way it is in terms of the effects of gravity, how gravity keeps galaxies rotating, that there seems to be some missing matter there. So we've got this thing called dark matter, but also the universe is expanding, and that expansion is accelerating, which would indicate that it's expanding faster than we expect it to, which indicates something is pushing the universe apart. And that's kind of a key point in terms of how the universe is structured. So, Euclid's doing something really interesting. And while some early observations were released in May of 2024, the Quick Euclid Data Release 1 went live last week. And the public can look at this. As Mary Helen said before I started talking here, we were actually looking at some of these images. Our OPV team was, yeah, and the two of us were looking at some of these images just before this webcast. So you can go to a site called ESA Sky, just Google it, ESA Sky. It's got a web-based tool. It's available to the public. It's really quite easy to navigate, and it's absolutely worth looking at.
Yeah, it's actually been a trend with all these big missions over the past couple of decades to make the data publicly available because they're just simply such massive data sets and such big missions. Sometimes like the principal investigators who sort of put the mission together and stuff get sort of first crack at the data, but after a certain time period, they just release it to the public because there's so much there and there's so much more that can be mined out of this data. I mean, even, earlier missions like Galileo and well, Cassini, now that it's over, and some of those, they're still mining results out of this data because there was just so much that was sent back, and that you can just keep finding new things in it. So a lot of these big astronomical projects and these big satellites, uh, and these big observatories, like for a little while, the people who are working on it sort of get first crack at the data because they put so much work into it. But then they're just like, look, like anybody who wants the data and can figure out something to study with it, here it is. So you've got, like this real mass of publicly available data, which allows us to really sort of expand the science. Because rather now than everybody having their own little sets of observations and you work on your own data, this kind of sharing that goes on is quite spectacular. It's happening in some other fields as well, but astronomy, I think, has really been, to some extent, on the leading edge of these public data sets, and having like the ability for the public to get involved. I know years ago, the Kepler mission, if you remember that one that was looking for extrasolar planets, fairly early on in the mission, they had so much data. They were getting citizen scientists to go through the data and search for extrasolar planets. And I did a bit of that myself. And I was actually one of the people who found one of the planets, within the first couple, found a planet within the first couple of years. It was kind of thrilling, but I was just doing it as a citizen scientist, just some with an interest. And astronomy really has been one of the first to do these kind of things because we have so much data. I don't know if you remember it, Paul, but the SETI data sets when they were first getting people to do processing on their home computers. And that's going back, oh, even, like before 2000, where you could download the software and run in the back. So it's like I said, astronomy has always been, I think, very sort of in a way open source where, they keep the data protected for a little bit so that the people who worked so hard, like, ran the project and everything can find, get the first publications out. But after that, it's sort of like, there's just so much here. Here it is. Come and see what you can find in it because we have so much data. We don't know what to do with it. It's just like,
Well,
it's simply beyond the capability of any one person or one research group to sort of analyze everything that gets pulled down.
Well, yeah, there's a couple of different aspects to this. I remember I was working on a number of remote sensing projects, and these were Earth-based projects back in the very early 1990s at the University of Bergen in Norway. And but we were getting a lot of data from Earth observing satellites, and that was when the first big bubble of data. We started to get, gigabytes per day, and this is a time where you couldn't get a hard drive with, a megabyte. And so we were getting gigabytes of data per day, and now we're pulling in exabytes, multiple exabytes. So that's 10 to the 9, 10 to the 12, 10 to the 15, 10 to the 18 bytes of data, daily on science from just astronomy and spacecraft. And, so that has a couple of implications. How do you store it? How do you search it? Data science is a really big component of this. How do you process it? You talked about the SETI project. That was one, but that process where you had a screensaver, which in the background, which made pretty pictures, and in the background it was your computer, when it wasn't doing anything else, was processing and looking for little bits of signal and so on. But that process is called gamification. And again, that university that I was working at in Norway, they were kind of specialists on it, and they were doing it with more biological applications, but molecule shapes and so on. But that is a whole area of data science. How do you gamify something so you can start to use distributed computer networks, people's home computers, just to break a little chunk of the data? And so that's one way citizen scientists get involved. But you've also got more active process where people can process the data. As I said, when Juno was launched towards Jupiter, there was no real interest in putting a camera on it. They were more interested in the magnetometer, and a few other instruments. But someone had the bright idea, and it was a brilliant idea. Let's just take a webcam on there. And, it probably won't last that long because we're flying very close to Jupiter. It has been the biggest success because the public likes space. They're very, very interested in it. And it's easy to be involved. Astronomy continues to be one of the very major fields where amateurs make huge contributions to the field, as do professionals. I'm studying to be a professional astronomer now, but I was an amateur as long as I can remember, and I've known people amateurs who've had papers published and whatnot. It's very exciting, and having the public involved there's nothing quite like it. It's just great.
I mean, and like, and astronomy led to this doing other things. You mentioned biology, but there are quite a number of areas. I don't know if you've ever heard of a project called Zooniverse, and they started with just looking at galaxies, and I think it might have been galaxies and possibly variable stars, but they've expanded into so many areas, up to things like deciphering like old scrolls and stuff. Now AI may take over some of this, but you still need the human eyes on it, to take a look at it and to look at the sheer volume of data. I mean, if you talk about citizen scientists, a lot of comet discoveries are actually made by quote unquote amateur observers, simply because space is so big, and they focus on this, where for most research scientists, that's not what, the kind of thing they're after. But most comets now are actually discovered by, generally amateur observers, because they're the ones sort of searching the sky specifically more for um, cometary bodies. Continuing on the whole space flight thing, new rocket launches are always a big thing, a very interesting thing going on in Europe right now. Germany is trying to launch its new Spectrum model of rocket. This is a fairly small one. For a long time, people launched from various islands in the Atlantic or the Pacific. Or you had, of course, launches from Florida because you could launch them out over the ocean. And there were advantages to launching, obviously, closer to the equator. There's sort of various physics that goes on that makes it easier. But what's interesting is Germany is now trying to launch one from up in Norway, uh, from an aerospace location there. I know they're talking also about launches directly from Britain. I think they were working on that one. Um, but this launch one was ISAR Aerospace. They were supposed to launch today, but because of the weather, they had high winds, so they decided to delay. But the Spectrum rocket would become the first orbital flight to originate from the European landmass. Um, and part of this is competition for satellite launches, right? Everybody's trying to launch satellites. And what's interesting about Spectrum, it's not a particularly large rocket. Obviously, the first one will not carry a payload because its, first launch is very risky. But, there was an interesting comment in one of the articles. It's sort of like Spectrum has the potential, if they've got it right, to be the first rocket that on its launch actually sort of makes outer space on its maiden voyage, right? Most, initial rocket launches are spectacular failures and don't sort of reach space, don't reach orbit. Um, but they're wondering if Spectrum could be one of the first to actually reach orbit without that kind of spectacular failure first. Now, they're warning people like this is the first rocket launch of this type. There are many, many things that can go wrong. I mean, I seem to remember like one person describing rocket launches as you're strapping a bomb to your back end and hoping nothing goes wrong and you end up in orbit. Um, So there's a lot of potential for things to go wrong with rocket launches because of the sheer amount of power in these systems. But it's kind of interesting that even in this day and age, people are still developing new rockets. They're launching now from places they never launched before. But with sort of satellites, with things like satellite internet and everything, becoming one way that, technology is going. Um, More and more rocket launches become, more and more important, whether you're just putting a smaller satellite in orbit or whether you're aiming to get to the moon and later to Mars. So the number of rocket launches actually is continuing to increase, and the number of companies like this German startup with its Spectrum rocket, you're seeing sort of more and more of this going on. Now, from the astronomer's point of view, it's a little bit, annoying at times because I'm sure we've all seen the train of satellites go by overhead when we were being observing, and they are bright and they do sort of interfere with other night sky observing. So there's depth sides to this as well. But certainly, like rocketry is still in some ways, like a pretty young technology. Yes, we can do it, and yes, we can put them up, but we still have pretty regular and spectacular failures. And any kind of new one goes through sort of a series of mishaps until they sort of get it, as you said with the Ranger missions earlier, until they kind of get it right. And the Spectrum is just kind of the latest in this sort of long line of rockets that they're trying to, excuse me, sort of trying to get up and going. So,
Yeah, it's interesting because I mean, launch technology and rocketry, it hasn't really significantly changed in how it does things, but it is approaching a period of mass production and high repeatability. And I think you'd have to give SpaceX credit on that. But because you can get the cost per kilogram into orbit or beyond orbit down so much, it opens possibilities. I mean, we talk about the satellites, interfering with observing. I mean, Starlink is it provides a very good service, and it provides a service in geographically challenged areas. And, I mean, it can be a little controversial now. We're not going to talk about that here, but it is up there. And I remember I was working on a project in Nigeria in about 2010. It was a telecommunications project. And one of the things we were talking about was putting up medium Earth orbit satellites to provide a satellite communication network for developing countries. And the killer was there was not enough low cost, reliable launch technology to make this cost feasible. But now if you can put up, you know, in one launch, 25 satellites, let's say, or 23 or whatever the number is, and you've got a lot of rockets you can launch and you can reuse the rockets, suddenly the economics of that change. And this is one of the things, Germany launching this rocket, they're developing, they're building on other companies' technologies to develop launch capability. You've got SpaceX, you've got Blue Origin, you've got Rocket Lab, you've got other companies doing this as well. Some of them will succeed, some of them won't, but we're getting better and better and better access to space.
Yeah. And I think with the satellites, the other thing, of course, that's coming up is they're working at making them smaller and smaller. So you end up with the tiny little cube satellites, that are the size of a lunchbox, that you can sort of put a whole swarm of them out there, and get a lot done rather than having to launch these sort of massive, school bus size things. That again, if it's price per kilogram, you can launch a whole lot of like little nano satellites or cube satellites for the price of that one massive project. So this is the other thing they're kind of looking at and moving towards a lot in space.
Yeah,
So
well, if you remember from a couple of years ago, the Didymos impactor, um, it took pictures on the way in as it was coming in to hit this asteroid, but we don't really have pictures of the impact because the impactor was the camera. But what and it goes back to what Ranger did, but on the same mission an Italian CubeSat, and I think it was a 6U CubeSat. So that's kind of, you know, about the size of a big bread box. Um, or a small cooler. But it was launched as well, and it followed in the wake of, it was following behind the impactor, and it did get some images. They were low resolution, but it was a cheap, add-on to the mission. And they got some images of the impact. So CubeSats are, yes, another technology, that's changing how we explore space. Another famous one was Light Sail, which was basically put up by amateurs in the Planetary Society and tested technology for light sails, which is using solar wind to change the orbit with a large, kind of think of it as an aluminum foil parachute almost that's in space, and the solar wind's pressing against it with a very little bit of inertia, but it's pushing the satellite up in its orbit. And these were all amateur projects. And that has spin-off because then NASA has launched one and the Japanese Space Agency have launched one. And they're doing more studious analysis of this technology. So there's a whole bunch of synergy and things coming together in space science and in astronomy. And it's a fascinating time to be alive, actually, and working in the field.
yeah. Oh yeah, I mean the space exploration thing is just it's hard to keep up sometimes with everything that's going on. So I think I will leave it to you maybe to wrap up in the last few minutes, what we should be looking for in just for your amateur observer, what's up in the night sky, if we get any skies that are actually not cloudy and miserable for the next week. What have we got out there to take a look for?
Well, as I said, I'm of two minds about this entire thing because exams are coming up and I really should be studying, but it's always very tempting to take out the telescope. So, we're getting toward the end of winter. Well, actually, we're in spring now, but when you look at the night sky, you're still seeing the winter constellations, and you can look up in the sort of southwest after sunset, and you'll see Orion. You can always identify it by its belt, and if you go from, and that's a great object to look at with even binoculars, because look just below the belt and there's a beautiful nebula there, the Great Nebula in Orion. And then you can go up and look a little north, look a little up, almost straight up, you'll see Jupiter. Venus is still in the night sky after sunset. Mars is near Jupiter, not terribly far away. And interestingly, the moon is not in the sky right now. It rises quite late at night. Uh, and that gives us an opportunity for something which has been going on for a couple of years right now, because we're at the period of solar maximum. So there's a lot of sun activity. And of course, the sun's not in the sky at night, but but it is putting out a lot of particles which interact with Earth's atmosphere and can create aurora. And because there's so much activity, the aurora are coming further and further south. So we're often getting aurora, evenings in the GTA. Now, you can maybe see a little bit of the effect in Toronto where there's a lot of light pollution. But if you go north or east or west, you can't go south because of the lake there. But if you go north, up towards north of Barrie, or maybe head out towards Lake Huron, eastern part of the province, sorry, western part of the province. There's some dark sky areas. You can get some really amazing observing of the night sky. Plus, if there's aurora, you're going to see that too, and it's fantastic. And you can find out whether there's aurora predicted. Just look up, on Google. Is there going to be any aurora tonight?
Yeah.
And if you've got your computer set up properly, it'll know where you are, roughly your coordinates, and it'll give you an idea of what the space weather looks like and whether you can see anything in the night sky when it comes to aurora. But the nice thing about being an astronomer, an amateur astronomer, professional astronomer, is there's always something in the sky going on. That's why it's one of the most satisfying uh, amateur scientific pursuits there is.
So just the only thing I'll say about the aurora is my other hat is as a geophysicist, and it's played hell with my field work the last 2 years, because if you want to do magnetic observations and some of the signals you're looking for are fairly, small, when you get a lot of solar activity, it kind of trashes your observations. So there are some downsides, unfortunately, to this solar activity on other fronts. But
And of course, it can affect electrical grids and so
yeah,
on. So absolutely, there's always a downside.
there's always a downside. Okay, so I think we're getting close to 10 o'clock. So thank you very much, Paul. We can wrap it up. I hope everybody has enjoyed our discussion tonight. Again, if you're watching this recording later and you have any questions, you can certainly always email the observatory, sort of observe at sort of that yorku.ca. But again, thank you everyone for listening to York Universe, the astronomy astrophysics program written and presented by the students, faculty, alumni, and friends of York University. Your hosts this evening have been Paul Macklin and myself, Mary Helen Armour. Again, you can always connect with the observatory on Instagram. Their handle is at YorkU Observatory. We have a Facebook page of Allan I. Carswell Observatory. And you can check out the website, the yorku.ca Science Observatory, for various show notes and sort of discussion, and to find out what other upcoming events you have. Again, thanks for tuning into York Universe. Hopefully in the near future, we'll have some clear skies for good observing, and good night to all.
Good night, everyone.